Hello, welcome back again to the channel. In this video we're going to discuss this integral, natural log of square root of x plus square root of x plus 1. Okay, the first time we see this problem, we are bothered by this square root x and square root of x plus 1. We wish that we can get rid of them, right? And our experience tells us that when we have some equation like this, usually the technique is we square both sides several times until we get the x. And so we wish that we can do something like that as well to this. But this is not an equation. There is no left hand side and right hand side. Well, actually there is, right? So there is this I here. If we multiply this I by 2, then we multiply also the right hand side by 2 here in the front, on the front, right? But by the property of the natural log, the 2 can go up here, so it's become ln of this squared. So that's it. We can square this expression. So what is the square root of x plus square root of x plus 1? So we square this, become x, and then we square that, become x plus 1. So we have 2x plus 1, and then we have twice of square root of x times x plus 1. Okay, and we will put this 2 inside the square root. Okay, so then the result will be 4x squared plus 4. Okay, so let's replace that with this. Okay, and whenever we see a square root, usually the technique is using a proper substitution, so that after we do those kind of substitution, then we can get rid of the square root. Usually there are 3 types of integral that containing square root, something of this type, or this type, x squared minus a squared, or that type. And then for each of this type, we can put the right substitution, so that after we substitute it, then there is no more square root. Okay, so then when we have something like this, we would like to rewrite this in terms of one of these. Okay, then the natural way is that we would like to complete the square for that expression. So 4x squared plus 4x. So 4x squared is coming from squaring 2x. But 4x can be obtained from 2 times 2x times 1. But if we do this completely, we square this, we have 4x squared plus 4x plus 1. So we need to subtract 1 to have exactly back 4x squared plus 4x. Alright, so now our integral become 2I is equal to natural log, that's 2x plus 1 plus square root of 2x plus 1 squared minus 1 dx. Now if we look at this expression, this integral screams for something. What is that? See, everything is already in terms of 2x plus 1. It begs us to do a substitution. Let's do it w equal to 2x plus 1. Then we have dw is equal to twice of dx, meaning that we can replace dx by 1/2 of dw. Okay, so in general then we can replace this dx in terms of dw, and then each of these we can replace it by w. So we'll be able to rewrite this integral in terms of w. Okay, so first of all, when we replace dx by 1/2 dw, we don't like 1/2 expression. So let's multiply both sides by 2. So we have 4I is equal to integral of ln w plus square root of w squared minus 1, which is twice of dx is dw. Okay. Now our previous experience with the natural log function, we get the antiderivative of the natural log by doing what? Anyone remember? We solve it by integration by parts, right? So let's just give it a try to use integration by parts in this situation. So then we have, this is our u and that's our dv. So according to integration by parts, we have u times v ln w plus square root of w squared minus 1, okay, plus or minus the integral of v du, right? So v is w, and then we need to take the derivative of that, which is 1 over u plus w plus square root of w squared minus 1 multiplied by the derivative of this. The derivative of w is 1, and the derivative of square root of w squared minus 1 is, what's that? Remember that the derivative of square root of x is 1 over twice square root of x. So the derivative of this will be 1 over 2 times square root of this, and then we multiply by 2w. So 2w divided by 2w squared minus 1 plus constant. But we can cancel the 2. Okay? So let's call this guy as j. So we have j, let's simplify j, is equal to integral of w over w plus square root of w squared minus 1. Okay, and then we try to make 1 to have the same denominator as this. So we have square root of w squared minus 1 plus w divided by double square root of w squared minus 1. What coincidence, what a coincidence. We can't cancel those parts. So then we're left with the integral of w over square root of w squared minus 1. But we are kind of familiar with that expression. When the last time we saw this expression? There, right? So remember that we get this expression from taking the derivative of this. So the derivative of this is equal to that, meaning that the integral of this is equal to that. Okay, so therefore this is equal to square root of w squared minus 1, you don't need c over here at the moment, plus c. Okay, so let's put everything together. So for I is equal to w natural log w plus square root of w squared minus 1 minus j minus square root of w squared minus 1 plus a constant. So that's the answer, and we just need to rewrite everything back in terms of 2x plus 1. Okay, so let's find the I. So we divide both sides by 4. So we will split the 4 as follows, right? So that's the 4i. Okay, so I will be, so 1/2 is going there, and another 1/2 will be raised to this power here. Okay, and then we have 1/4 here. Okay, so I is equal to, let's write back w is 2x plus 1. 2x plus 1 over 2 natural log 2x plus 1 plus square root of 4x squared plus 4x to the power of 1/2. Remember that we have this expression from squaring this guy. So taking the square root of this guy will give us back this guy, right? So this to the power 1/2 is exactly square root of x plus square root of x plus 1 minus 1/4 of w squared minus 1 is this, right? 4x squared plus 4x. Okay, let's take out the 4. Let's become 2 here. This will become 1/2. And this one is nicer to be written as x times x plus 1. So we can see where this x and x plus 1 comes from. So that's it. This is the answer. Okay, so let me copy this one here, because after this we will redo the problem from the middle by some other approach. Okay, let's copy this, x times x plus 1 plus c. Okay, we want to keep this and want to erase everything up here. Okay, I wish all the viewers already understand all of this, or taking the note if necessary. Okay, okay, let me erase this. So the step from here to the next line is kind of unnatural, because, well, it is indeed natural log, and it is indeed that we find an antiderivative of ln x by using integration by parts. But truth to be told, that actually I found that we need to use integration by parts is by pure luck. So after trying several methods which not working, and then luckily I said to myself, okay, let's see what happens if we use integration by parts here, and we get the answer, right? So actually the more natural approach is that when we solve this kind of expression, we want to get rid of the square root by substituting the right variable here. So the trigonometric identity that resembling this expression is secant squared t minus 1 is equal to tangent squared t. Okay, meaning that if we replace w by secant squared, then this guy will turn into tangent squared t, and then when we take the square root, is voila, we don't have square root anymore, because the square root and the square coming from the tangent is cancelling each other. Okay, so then the more natural things to do is that we use substitution w equal to secant t, right? Okay, from here, okay, just keep it that way. So then 4i is equal to integral of ln of, so I need to say a few words here. So because of this, the x need to be positive. Since x is positive, w is positive. So we will be fine if we write that expression as natural log of absolute value. So W is secant t, and then remember that when we substitute secant t here, we have this expression turned into tangent t. And then we have d of secant t. Okay? Well, when I stuck here, I did follow through up to this point, but one thing that I didn't realize that this expression is familiar. So anyone remember what is this? So actually this guy is the integral of secant t dt. Okay? So now we will use integration by parts by using this as our u and this is our dv. So then according to integration by parts, u times v secant t ln secant t plus tangent t minus integral of secant t times the differential of this. But because integral of secant is that, then the derivative of this is equal to secant. Okay? And we are lucky because the integral of secant squared is easy. What is that? This integral is equal to tangent t. Tangent t plus c. Right? Okay, so basically we are done. This is 4 times I. Therefore I is 1/4 of this minus 1/4 of that. Right? And then secant was w. Okay? And w was 2x plus 1. So 1/4 2x plus 1 ln secant is w is 2x plus 1. This is exactly what we did before. And this is square root of 4x squared plus 4x. If we free one of the 1/2 from here, so I mean this is equal to 1/2 and 1/2, right? With 1/4. And then we take this 1/2, one of them, and then put it here. The square root of that is that guy. So then we have ln of square root of x plus square root of x plus 1 minus 1/4 of tangent t. So let's use some right triangle. So we have that w is secant t. So pretend that this is secant, and so pretend this is t. Secant is this over that. So this would be w over 1, and here we have square root of w squared minus 1. So tangent t is exactly this over that, square root of w squared minus 1. But w squared minus 1 is 4x squared plus 4x. But this is the same as this one. Okay? So right. So we are done. So as you can see, we have 2 methods. Well, basically one method up to this point, and then basically from this point on we just need to use integration by parts. Right, thank you very much for watching. Don't forget to hit the button if you like the video and subscribe if you have not yet. See you again on the next video. Bye bye.